Gotcha. day, grade 10 learners. Welcome to our mathematics lesson. I am Skolile Ngube. This lesson is proudly brought to you by the Gauteng Department of Education. Right, today, grade 10s, we are going to be looking at what? Trigonometric ratios, but we're going to look at angles in the Cartesian plane. Do you remember what we did in the previous lesson, grade 10s? We looked at what? Angles in what? In a right angle. So today we're going to define the trigonometric ratios for angles in the Cartesian plane. Are you ready for the lesson? I want you to be ready, grade 10s. Okay, today we have to move together slowly and make sure that we understand everything that we're going to be doing. Understand everything. Remember, this is the first time you are doing trigonometry, and you have to understand everything so that you enjoy this topic. Okay? And remember, our WhatsApp line 064 748 8913. Please send us your input. We don't want anyone to be left behind. That's the most important thing for today's lesson. Okay? Right. If you need time, you tell us. Okay, you want to ask question, do so. You want to show us your work, do so. Use the line 064 748 8913. This is what I expect from you today, grade 10s. I want your book to be there in front of you, your exercise book where you write your notes. Your ruler must be there, your pencil, your calculator, and your pen. Please make sure these things are ready. Because now when you are moving, we can't be looking for rulers and all those things. We just have to move nicely together, okay? Right, make sure that those things are there. Now, can you just do that now? So that when you're moving together, no one is going to be disturbed. Okay? Should we start? We're going to start our lesson. Right, now, let's start. By the end of this lesson, you should be able to do what? Which is very, very important. The aim of this lesson, you should be able to extend the definition. Remember, we defined the trigonometric ratios in the previous lesson. What did we say? Sine theta is equal to the opposite side divided by hypotenuse. Cos theta, adjacent side divided by hypotenuse. Then tan theta, opposite side divided by adjacent side. We define those three trigonometric ratios like that, isn't it? So today we're going to extend our definition for angles that are between 0 and 360 degrees. You see now, how can you talk of a right angle triangle with an angle which is 120 degrees? It's impossible, isn't it? So now we're not going to be looking at angles in a right angle triangle, but somehow we're going to use what we learned in the previous lesson, okay? It's not like we're throwing it away. We're going to use it. It's very, very crucial for today's lesson. Okay? Right. So refer to the CAPS document, page 23. All right. We did right angle triangles. Remember in the previous lesson, grade 10s, we are dealing with right angle triangles. The ratios that we talked about, I want to emphasize this, is only for right angle triangles. Please, I don't want to see scalene triangles now, isosceles triangles, then people start saying opposite of adjacent. There's nothing like that. We're dealing with right angle triangles, and triangle with a 90-degree angle. Then we used Pythagoras theorem. We're going to use it a lot today. Trigonometric ratios. I even gave you the acronym SOHCAHTOA. We're going to use it today. We're not going to throw it away. It's very, very essential. We need that. Some people are going to benefit from using that, okay? Then Cartesian plane. We know what a Cartesian plane is. The x and the y-axis. The x-axis is horizontal. The y-axis is vertical. We're going to be using those things today. Right. Now, remember we started with our baseline activity. We want to remind ourselves about what we learned in the previous lesson and also make sure that we remember these things so that we can use them in today's lesson. Right, solve for the length of the unknown side, x, in the triangle, and thereafter write the value of sine theta, cos theta, and tan theta. Let's do it this way. I'm going to give you 2 minutes to find the length of AB, which is x. Remember, triangle ABC is a right angle triangle. So let's find the length of side x. I'm going to give you 2 minutes, and then we do it together. And then after that, we're going to write our three trigonometric ratios: sine theta, cos theta, and tan theta. Leave your answer in set form. Don't write it as a decimal. Set form, it can be like root 3, square root of 3, or 2 root 3, something like that. Okay, you leave your answer in set form. Let's try for 2 minutes. Let's find the value of x. Right, well done, grade 10s. Did you manage to get the answer? Right, let's mark our work. Please write your corrections. You can write your corrections as we discuss, isn't it? Okay. Use your pencil to make corrections. If you got it right, you mark your work. Okay. Right. You mark with pencil. Then if there are corrections you have to make, you use your pencil to make those corrections. Okay. Right. Now, let's do it. Now, why do I say 10 squared is equals to x squared plus 5 squared? Why? Because of the Pythagoras theorem. Remember that. So we have our right angle triangle here. So AC is the hypotenuse. So it's going to be AC squared is equals to AB squared plus BC squared. Why are we saying that? Pythagoras theorem. You see, we're applying Pythagoras theorem here. Okay, or Pyth. Some people just write Pyth and then it's fine. Right, so that's why we have that. So AC is 10, so that's why we have 10 squared here. And then AB is x, we leave it as x, and then BC is 5, so that's why we have 5 squared here. Then what do we do after that? We want to find x. What do? We can transpose, isn't it? We're talking about transposing now. Okay, it's faster. Instead of saying subtract 5 squared both sides, you can do that, it's fine. But now in grade 10, you can do that. We know that when you're transposing, bring the 5 squared this side, is going to be 10 squared minus 5 squared. Okay, and then we can square root both sides. I think I moved fast here. Let me show you. Okay, 10 squared minus 5 squared is equals to x squared. Do you see that? And then what do? We square root both sides. Square root both sides, cretins. And then you see, that's what you have here. What is the square root of x squared? You learn this in grade 8 and 9. The square root and the square, they what? They cancel each other out. Then that's why we remain with this x here. So this remains as x. So it becomes 10 squared minus 5 squared is equals to x. Right, 10 squared is what? 100. 100 minus 25, that should be 75. What is the square root of 75? Or you can do this, you can just put this thing in underneath the square root sign straight away. And then you get your answer as what? 5 root 3. So our x is 5 root 3 grade 10s, okay? So let's write here 5 root 3. Let me write it inside because maybe sometimes I've animated and then you make it clumsy. So x is 5 root 3, okay? Now I want you to write the three trigonometric ratios. I'm going to give you 1 minute. We know these things, right? Sine theta, cos theta, tan theta. Right, remember, I'll write SOHCAHTOA for you and then I'll give you 1 minute. SOHCAHTOA. Am I right? Yes. Right. Write the three trigonometric ratios: sine theta, cos theta, tan theta. 1 minute. Let's try. Well done, grade 10. Did you get your answers? I really hope so. I really hope so. Right. Sine theta. Sine theta is opposite side over hypotenuse. Don't just say opposite. We talk about sides here. So sine theta is opposite side over the divided by the hypotenuse side. Okay. Right. So it's going to be sine theta. This is opposite. You see, it's on the other side. Opposite. 5 root 3 divided by 10. Then we can simplify that. If you put in the calculator can simplify for you. Right, it's actually root 3 over 2. Those who have done special angles, maybe they know what this angle theta is now. When angle theta is root 3 over 2, okay? But let's leave it for now. Right, now, and then cos theta. Cos theta is adjacent side over the hypotenuse, adjacent next to. That is 5. So it's going to be 5 over 10, which is half. Which angle will give you, we say cos something, get half, okay? Right, don't worry about that for now. Cos theta is 1 over 2. Cos theta is 1 over 2. Mark that. If you didn't get it right, write the corrections, okay? Right, and then we move on to tan theta. Tan theta is opposite over adjacent side. Opposite side over adjacent side. So it's going to be 5 root 3 over 5, which is root 3. Okay, mark that. Did you get everything correct? Right, well done, well done, well done, well done. Now, are you ready to learn something new, grade 10s? We did this last week, but we're going to use it today. Are you ready to learn something new? Let's be ready, let's be ready. Okay, we're going to be sort of investigating, want to find out something, okay? Right, so let's take it that way. Now, how do we measure angles in the Cartesian plane? How do we do that? We've been dealing with angles in a triangle, in a right angle triangle now. But what about angles in the Cartesian plane? We're talking about an angle that can be 45 degrees. We're talking about an angle that can be 110 degrees, which is more than 90 degrees. We're talking about an angle that can be 200 degrees, which is more than 180 degrees. We're talking about an angle which is more than even 270 degrees, which can be 300 degrees. Now, how do we measure such? Because you cannot have a right angle for triangle for that. You see that? So pay attention and follow the instructions. I'm going to be telling you to do things, okay? When angles are measured anti-clockwise from the positive x-axis, let me go to this part first before I go back to that point. The vertical axis is the what? Who knows? The vertical axis is the y-axis, vertical. When you're standing, you're vertical. So this is the y-axis. And the horizontal axis is the x-axis. I'll go back to the point. Right, where the two axes intersect is called what? The origin. So this one is x, this one is origin. We usually write O there for origin. Okay, you see that? Now, I said, when angles are measured anti-clockwise, from where? From the positive side of the x-axis, which means this side, from here. Anti-clockwise, the clock goes this way. Anti-clockwise, this way. So when I'm saying anti-clockwise, we're going this way. And then clockwise, we're going this way. So when measuring angles, when angles are measured anti-clockwise, like this, from the positive x-axis, they are considered to be positive. So this is a positive angle. We're going anti-clockwise, grade 10s. We're going anti-clockwise. Okay? Remember our WhatsApp line 064 748 8913. Remember I said no one should be left behind in this lesson. I want you to understand everything. Right? Anti-clockwise, we're going this way. So we'll be going this way in today's lesson. But just for your knowledge, right? When angles are measured clockwise from the positive side of the x-axis, they are considered to be negative. Like this one is a negative angle. We are going to be doing negative angles very soon, okay? And then just know that this is a negative angle, but it ends there. But for anti-clockwise, we'll go in all the quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay? Right. I wanted you to know that. Now, let's move on. For positive angles, we'll do angles in all 4 quadrants for the Cartesian plane. Right. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. That's what we are doing today. We're going to define the trigonometric ratios for angles in quadrant 1, quadrant 2, quadrant 3, quadrant 4. Are we going to use opposite over adjacent? Opposite over hypotenuse? We'll find out. But now, I want us to do this before we move any further. I want us to draw 4 Cartesian planes. Please make sure that your work is neat and is big enough. If it means using the whole page, please do that, okay? So I want 4 Cartesian planes on your book. Right, let's do it together. Right, 1, 2, 3, 4, like that, okay? So once I'm done drawing my Cartesian planes here, also you should be done on your side, okay? Right, let's start. I'm going to draw my first one. So this, please don't, my work is not going to be neat because I don't have a ruler, but make sure you use your ruler there. Try to be neat. Okay, this is the first Cartesian plane. Right, this is the first one. 0 degrees, 90 degrees, 180 degrees, 270 degrees, then 360 degrees. Okay, and then this is y, this is x. Right, so this is the first Cartesian plane. You can even write this is quadrant 1, quadrant 2. You see, we're going anti-clockwise. Quadrant 3, quadrant 4. We're going anti-clockwise. Anti-clockwise. Right, let's go to our second diagram on the right. Okay, right, draw your second diagram. Everyone now should be having the first diagram. Everyone must be having the first diagram. Right, the second diagram, let's draw it. Okay, this is the first diagram, second diagram. Second, you can even name it diagram number 1 so that you know when I'm saying diagram 1, diagram 2, which one I'm talking about. Right, this is the x-axis, this is the y-axis. This is 0 degrees, 90 degrees. We're going anti-clockwise, 180 degrees, 270 degrees. What else did I miss? Oh, the origin. What else? Oh, 360 degrees. In quadrant 1, quadrant 2, quadrant 3, quadrant 4. Second diagram. We're going to have 4 diagrams. Okay? Right. Make sure you have your 2 diagrams with you. Just the diagrams, nothing else. Right, let's draw a quadrant diagram number 4. Okay, underneath diagram 1, sorry, not diagram 4, diagram 3, underneath diagram 1, but I can't because of space here. I'll just shift it a bit. This is my y-axis, x-axis, okay, the origin. 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. What did I miss? Oh, quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Right, we have our 3 diagrams now. 3 diagrams now. Please make sure you have these things. We are moving together here. We're moving together here. So no one should be left behind. Please, you can't learn mathematics by just listening. Okay? You have to do it. You have to do mathematics, not by listening. You're listening, you only get what? 5% of the things. You do it, you'll understand everything. Right, x-axis, y, this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees, okay? Then the origin, right? Then let's name our quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Right, we have our 4 diagrams now. Right, 4 diagrams. Must have that. Now remember our WhatsApp line 064-748-8913. Are we done with our diagrams? Now let's look at our angles now in the different quadrants, okay? If I say diagram 1, you're drawing on diagram 1. If I say diagram 2, you're drawing on diagram 2. Diagram 3, diagram 4, like that, okay? Let's start. Right, diagram 1. You're drawing on diagram 1 now. We are looking at angles between 0 degrees and 90 degrees. These are acute angles. The angles between 0 degrees and 90 degrees. Draw your arrow like that and your angle theta like that. And then these are the angles between 0 and 90 degrees. So quadrant 1 is for angles between 0 and 90 degrees. Copy that. 30 seconds. I'm not going to go anywhere. I'm just giving you 30 seconds to do that. And then we go to diagram 2. I'll show you how to write it. Okay, let's do it. Right. Well done. Well done. I'm also done here. I was trying to see how far you can go. Right now, quadrant 2. Quadrant 2, we're drawing is which angles? What do you think? What will be the size of the angles? Between what and what? Quadrant 2 will be between 90 degrees and 180 degrees. You see, these 90 degrees, we call them boundaries. 90, 180, 270, 360. These are the boundaries. Then there are angles between that. There are angles between those boundaries. So quadrant 2 are angles between 90 degrees and 180 degrees. That's quadrant 2. But the angle we're looking at, I know people get confused. They start thinking that the angle is this one. No, 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 no. These are the angles. An example, which angle is between 90 degrees and 180 degrees? 120 degrees, 150 degrees. We're talking about those angles. The angle here is this part. Remember we said we're measuring from the positive x-axis. We're measuring from here. Angles are measured from here every time. And we're moving anti-clockwise. So the angle we're talking about is this one here. So these are the angles between 90 and 180 degrees. Again, I'm going to give you 30 seconds to copy this. That you're doing this on diagram 2. Let's do it. Right, okay. Great, are you done? I really hope you're done, great. Okay, let's move together. Please, if you feel like you need time, please do so. And you have to do it now, not at the end of the lesson. Do it now if you need time so that we can try to adjust our time. Okay, that is diagram 2. Diagram 3. Which angles are we talking about in diagram 3? Angles between 180 and 270 degrees, okay? So these are angles that go 200 degrees, 250 degrees, 190 degrees. These are angles between 180 degrees and 270 degrees. Do you see that? So we're talking about quadrant 3. Draw your ray, okay? I'll tell you later. This is called the ray or the terminal arm. Okay, right. Draw it. And then the angle we're talking about is this angle here. That's angle theta there. So we're talking about angles between 180 degrees and 270 degrees. Okay, copy it for another 30 seconds. Are you done, Cretans? I hope so. I hope so. Please send us your input on 064-748-8913. Let's do our last quadrant, right? Quadrant 4, which angles are these ones? These are angles between 270 and 360 degrees. You're talking about 300 degrees, 320 degrees, 290 degrees. These are the angles between 270 degrees and 360 degrees. You see that? So they are in quadrant what? In quadrant 4. Angles between 270 degrees and 360 degrees. You see that? Now, you're wondering now, how are you going to be defining these angles in the Cartesian plane? That's the main purpose of today's lesson. We're going to be learning that because now we cannot use opposite over adjacent, adjacent over hypotenuse, but we are going to apply it somehow. Okay? All right. Okay. That's our main purpose of today's lesson. Right now, can you write that for 30 seconds for quadrant 4? Right. Well done. Well done. Well done. You must be having your 4 diagrams. 4 diagrams there with you now. Right. Now, I want us to check something. I want us to see something here. Yeah? Activity 1. Like we're saying, we're investigating, you want to see something. Consider point R on the Cartesian plane. I want you to write down the coordinates of R. Each small box represents 1 unit. If you check, this is 1, 2, 3, 4, 5. You see that? Then even going up, 1, 2, 3, 4, 5. So each small square represents what? 1 unit. So what are the coordinates of R? First, what are the coordinates of R? You can even say them. The x is what? X, remember, is from here up to there. And then x is horizontal. Do you remember that? It is very, very important for you to remember that x is, I see some people are not saying it. X is on the horizontal. Y, vertical. X, horizontal. Y, vertical. It is very, very important for today's lesson to know that. So the x is from there up to there. And then the y is vertical from there up to there. Okay. Can you see what I'm talking about? Let me show. Right by the side. From there up to there. That's what. So x is what? 4. You see? That's x. Y is 3. Okay. So those are the coordinates of R. Right. It says join O and R to create OR. Right. Let's do this. Draw another Cartesian plane. Let's do it together. Draw another Cartesian plane. Let's do it fast. Once I'm done this side, also it must be done. You don't need to draw the small squares. You don't need to draw the small squares. Okay? Just this. And then this is enough. Y, X. That's enough. Then 0. Then 0, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Okay? Right. R is 4, 3. Okay, must have a diagram like that. Okay, right, and then draw OR. Let's draw OR. Let's draw OR. Good. That's your OR. So you must be having a diagram like this for you. You need 30 seconds for that to finish. Let me wait for 30 seconds. Right, draw OR. You don't worry about the small squares. Just this diagram is enough. A diagram like this is enough. So OR. Okay. You have OR. Right. So you should be having something like this. Okay. Okay. So this OR is called, I mentioned this term, I said it's called the terminal arm or ray. And it's always positive. Please remember that R is always positive, regardless of the quadrant. It can be in quadrant 2 is positive. Quadrant 3 is positive. Quadrant 4 is positive. R is always positive. So this OR is called R, ray, terminal arm. So put R there on your diagram. Okay, good. Now, that's our angle theta. Put your angle theta there on your diagram. Okay. Oh, my diagram disappeared. Let me draw again. Even those who are behind now, you must manage to catch up. Okay. 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. This is the origin. And then we had R, which was 4, 3. And then we say this ray is R. Okay. You must be having that diagram there. Okay, like that. Now, okay. Right. Now, draw a vertical line from R to the x-axis. Let's draw the vertical line from R to the x-axis. Follow this part here like I'm going to show you. You see, draw like this. Right. After drawing this, what do you see, grade 10s? Look at these points, OR and the line that you have drawn, which is vertical from R to the positive x-axis. What do you see? Do you see a triangle? I can see a triangle. Okay, I can see a triangle. Let me see. Right. This is the triangle I can see. This one. You see? That's a triangle. What type of a triangle is that? It is a what? A right angle triangle. You see that? It is a right angle triangle. Right. Now, I want us to name this distance from here. Let me change the color of my pen. What happened to my pens? Okay, let me leave it. Right. And then from here up to there, is it X or Y? Remember, I said X is horizontal. Y is vertical. So what is the distance from there up to there? Is it X or Y? The horizontal one. It is X. Do you see that? It is X. And then what about this one? This distance from this point up to there. What is it? The vertical one on the opposite side of theta. What is it? It is Y. Do you see that? Now we have a right angle triangle here. Look at the angle theta. What is your opposite side for angle theta? This is your angle theta. What is the opposite side? Is it Y or X? It is Y. What is your adjacent side? Is it Y or X? It is X. What is your hypotenuse? Your hypotenuse is R. Do you see that? So now, instead of using opposite, adjacent side, opposite side, and hypotenuse, we're going to use X, either X or Y or R. And then we can be able now to define any ratio in any quadrant. Because now we're no longer using that. We're now using X, y, or r. And then we can define angles in any of the quadrants. Do you see that? Okay, so this is x. In this case, our x is 4, and then this is 3, which is y. You see that? Linking our thing to what we did in the previous lesson, opposite over adjacent, adjacent over hypotenuse side, something like that. Okay, now before we move any further, remember this. So our Pythagoras theorem, right? R squared is equals to x squared plus y squared, because R is the hypotenuse. So that's hypotenuse squared. X is the other side, and then y is the other side. So R squared is equal to x squared plus y squared. Please write that one down. Just next to your diagram. R squared is equals to x squared plus y squared. Very important. Okay. Right. I want to show you one point, which is very, very important. This is the point. Right. After drawing this circle here, for every point on the circumference, this Pythagoras theorem applies. For every point on the circumference of the blue circle. Right. Okay. Right. So now I can even draw here a line going to this direction. This is y, this is x. Y can be negative, positive. We're going to talk about that very soon. Right. So r squared is equal to x squared plus y squared. Even in quadrant 3, let me pick another pen. Even in quadrant 3, don't draw this, okay? We're discussing here, don't write anything, okay? We're just discussing, right? Even in quadrant 3, this will be your y, this will be your x. So this is r. R squared is equals to x squared plus y squared. Even in quadrant 4, I'll show you how to draw this diagram nicely. You will never have problems, okay? R squared is equals to x squared plus y squared. So for every point on the circumference, r squared is equals to x squared plus y squared. Okay? Right, now, one important thing that we've done. Now we need to define our 3 trigonometric ratios using x, y, and r. That's what we are going to be doing now. Okay? Right. Now, sine theta, let's go back to our quadrant 1. Sine theta is opposite over hypotenuse. If you look at theta, the opposite side is y. The hypotenuse is r. So sine theta is opposite side over hypotenuse, meaning that sine theta is y over r. I just added this so that you can remember it, okay? But otherwise, sine theta, for every quadrant, sine theta is equals to y over r. So now we can define, we've defined sine theta for all the angles in the 4 quadrants. It's just y over r. Done. Do you see that? We're doing all these things to come to this, for you to understand this, okay? I want you to do cos theta, tan theta. Please use x or y or r, just that. Okay, is your final answer. But you can start by writing this to remind you yourself, okay? Right, cos theta, sin theta, sorry, cos theta and tan theta. Very fast, 30 seconds, because we're running out of time. 30 seconds, can you try that? If you manage to do it, great hands. Did you get it right? But at least you should learn something. You have learned something, okay? Right. Sin theta is y over r. Remember that, okay? Right. And then cos theta is what? Adjacent over hypotenuse. Adjacent side. I keep on saying adjacent. Adjacent side over hypotenuse. So adjacent side is x, and then hypotenuse is r. So it's adjacent side over hypotenuse. Cos theta is x over r. Please write this one down. or you're marking it, okay? Because I gave you time to do it. And then tan theta, opposite over adjacent. Opposite is y, adjacent is x. So tan theta is y over x. Now we have defined the three ratios for angles between 0 and to 360 degrees. We've defined them. Can you remember what you said? Sin theta is y over r. Cos theta is x over r. X is horizontal, remember, y is vertical. And then tan theta is y over x. Sometimes I forget these things. And then I just have to write. I know my x is here, I just write it here. I know my y is here, I just write it there. I know my r is there, my hypotenuse is there, I just write it there. Then I go back to my SOHCAHTOA. It will work. Okay? Right. Now, done that part. Now we have defined the three trigonometric ratios now for all the angles in the Cartesian plane. Right. Remember that r squared is equal to x squared plus y squared. Now, very, very important. I want us to discover now these angles in the Cartesian ratios are going to be negative or positive in these different quadrants. Are we together? Right. We'll discuss point by point. Point by point. Please don't write this. I'll tell you what to write. Okay? Right. Let's look at the coordinates of point A here. And then after those coordinates, we discuss about the signs of the coordinates. Right. Point A, I will tell you because time is moving fast. So point A is actually x is 3, x coordinate is 3, y coordinate is 3. So here we can see that in quadrant 1, don't write, I'm going to give you notes, okay? In quadrant 1, the x coordinate, x is positive, y is positive. You can see that. Point A is in quadrant 1. X is positive, y is positive. Don't write anything, just listen. B, what are the coordinates of B? X is what? X is minus 4 there, and then y is 3. So in quadrant Q, X is negative, you can see that, and then y is positive. That's quadrant 2. Don't write it. You're listening, isn't it? X is negative, y is positive. So when I tell you this now, you have seen it, isn't it? When I give you news, just believe it now because we've talked about it. Then C, if you can check. X is negative and y is negative. You can see this is negative 3. These are examples, okay? Negative 3, negative 1. So x is negative, y is negative. And then D, we can see that x is positive and then y is negative. Okay? Right. And then this is what we discussed about, okay? What do you recognize about the signs of the 4 points on the Cartesian plane? We said in quadrant 1, x is positive, y is positive. In quadrant 2, x is negative, y is positive. In quadrant 3, x is negative, y is negative. And then in quadrant 4, x is positive and y is negative. Now, I want you to write this. Just write this, okay? Draw your Cartesian plane, and then you write the following. I'm going to give you 1 minute to copy the diagram. 1 minute. Just pass the Cartesian plane, and then you write here. X in quadrant 1, x is positive, y is positive. You can write as I speak. Right? Quadrant 2, x is negative, y is positive. Quadrant 3, I said quadrant 2, x is negative, y is positive. Quadrant 3, x is negative, y is negative. Quadrant 4, x is positive and y is negative. 1 minute. Let's copy that fast. welcome back, Cretans. We got a question, says, how do we measure angles on a Cartesian plane? It was the beginning of the lesson. I'm not sure if maybe you've been answered as we progressed, okay? But if you still need more clarity, please do send us your question again, okay? Sure, because this question was there before, just at the beginning of the lesson, okay? So if you're answered, please tell us that you're answered. If you're not, please send your question again or paraphrase it so that we can assist you. Right now, so we said this. We said, remember sine theta is y over r, cos theta is x over r, and then tan theta is y over x, okay? Right, in quadrant 1, don't write this, I'll tell you what to write. You must have your Cartesian plane with you there. Right, in quadrant 1, y is positive. We said r is always positive. So in quadrant 1, y is positive, r is positive. So it's positive over positive. So it means sine theta is positive in quadrant 1. Cos theta, x is positive in quadrant 1, y is positive. Sorry, r is positive. So it's positive divided by positive. So it means cos theta is positive in quadrant 1. Tan theta is y over x. In quadrant 1, y is positive, x is positive. So tan theta is positive in quadrant 1. So now, I don't want you to write all these things. In quadrant 1, just write this. All are positive. All the trigonometric ratios are positive in quadrant 1. Just that. So just have your Cartesian plane like this. You can draw another one. You just say all. It's fine. All. You can write your 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then 360 degrees. So all the trigonometric ratios are positive in quadrant 1. Okay? Right, in quadrant 2, x is negative and y is positive, isn't it? So now, sine theta is y over r. Y is positive. R is always positive. So sine theta is positive in quadrant what? 2. But what about cos theta? Cos theta is x over r. X in quadrant 2 is negative. So it's negative over positive. So this is negative. It means cos theta is negative in quadrant 2. Tan theta is y over x. Y is positive, x is negative. So negative divided by positive. So it should be positive divided by negative, which is negative. So it means tan theta is negative in quadrant 2. So it's easy to remember that it is only sine theta which is positive in quadrant 2. The other two are negative. So just write sine theta for quadrant 2. And then we go to quadrant 3. Okay? Quadrant 3. Sine theta, y over r. Y is negative, r is positive. Remember, r is always positive. So it means it's going to be negative. So sine theta is negative in quadrant 3. Cos theta, x is negative, r is positive. So it's negative over positive. So it means cos theta is negative in quadrant 3. And then tan theta, y is negative, x is negative. Negative divided by negative, you have positive. So it is only tan theta which is positive in quadrant 3, and then the other two are negative. So just write tan theta there for quadrant 3. So quadrant 1, all of them, all the trig ratios are positive. Quadrant 2, it is only sine theta. Quadrant 3, it is tan theta. And then quadrant 4, it is what? What do you think? It's going to be cos theta. You're right. Cos theta is going to be positive in quadrant 4. Let's check. Sine theta is y over r. Y is negative. R is positive. So it's going to be negative over positive, which is negative. So sine theta is negative in quadrant 4. Cos theta, x is positive, r is positive. So cos theta is positive in quadrant 4. But tan theta will be negative in quadrant 4 because y is negative and x is positive. You see that? So in quadrant 4, only cos theta is positive. The other two are negative. If you just remember this, you're fine with angles in the Cartesian plane. But how do we remember this? We have different ways of doing it, but I'm going to show you the most popular one, which is called the cast diagram. The cast diagram. But remember, when you're writing cast, we start with quadrant 4, in quadrant 4, not in quadrant 1. So C for cos in quadrant 4. C means cos theta here is positive. The other two are negative. A here means all of them are positive in quadrant 1. All of them are positive. Quadrant 2, it is only sine theta which is positive. The other two trig ratios are negative. And in quadrant 3, it is only tan theta which is positive. Cos theta and sine theta are negative in quadrant what? In quadrant 3. You see that? Okay. Right. Now, this is called the cast diagram. It is going to assist you a lot. Cast diagram. Please, 1 minute for you to have this diagram with you. Just 1 minute. And then after that, we go to an activity. We're not going to do a lot. We just end here. Then in the next lesson, we're going to bring more questions. Okay. The next activity, I will just teach you how to identify the quadrants. Okay. We'll just end there. How do you identify the quadrants? Then we'll be done. Okay. Just copy this, and then we go to the identification of the quadrants. Well done, Cretans. I really hope that, I think the last part I was just moving a bit fast, but we want to learn something, then we're going to apply what you're going to learn in the next lesson, okay? Right, please try to be fine. Thank you very much, Skuto Taro Secondary School. That's where the question came from. Please, we really need to know if you are covered so that we can assist you, okay? Even after the lesson, we can answer you. Please, if you understood, your question was, how do we measure angles on a Cartesian plane? It was at the beginning of the lesson. Are you fine after going through the lesson, or you still need more clarity? Please make us aware of that. Then we really appreciate your question. Okay, please let us know if you still need more clarity. Right, okay, great. Like I said, we're left with 6 minutes. I want us to be able to identify the quadrants given two conditions. Okay, I'll do the first one, then you try. I'll give you 2 minutes to try just two, and then I'll do the last one. Okay, just 4 of them. Okay, and then what we have learned today will apply in the next lesson. Okay, right, let's try. Remember the cast diagram. Cast diagram. You see, quadrant 4, only cos theta is positive. Quadrant 1, all of them are positive. Quadrant 2, sine theta is positive. Quadrant 3, tan theta is positive. Are we together? Right. Now, I'll do the first one. In which quadrant does the terminal arm of the angle theta lie? So now, given these two conditions, where is our terminal ray? Because they will say, without a calculator, with the aid of a diagram, solve this or simplify this. So you need to know how to draw these diagrams. It is very important. Okay? Right. Greater than 0 means what? Before we go any further. What is the meaning of greater than 0? You know the number line, isn't it? When the number is greater than 0, what does that mean? It means positive, isn't it? Just know that we're going to apply that even in functions. Greater than 0 means positive. Less than 0 means negative. Okay? Right, now, we want a quadrant where sine theta is positive and cos theta is positive. Which quadrant is that? Some of you may be trying that, okay? Try is fine, you can try. Which quadrant is, do we have sine theta positive and cos theta positive? You may have different methods, but I find the use of ticks working for me. Right, each ratio is going to be positive in 2 quadrants and negative in 2 quadrants. Okay? You know that, né? All of them are positive in quadrant 1 anyway. Okay? Right, now, let me try. I have my diagram. Let me write my cast. Right. Where is sine theta positive? Obvious. Quadrant 1, sine theta is positive. Where else? Here, this means sine theta is positive. Quadrant 2. You see that? And then I go to the second condition. Where is cos theta positive? In quadrant 1. Looks like I took the easy one. And then where else is cos theta positive? Here, C. C means cos theta is positive here. So that is positive there. Which quadrant meets the 2 conditions? Which quadrant is it? That's quadrant 1. You see that? So that's quadrant 1. Oh, I had my ticks. Okay, let me use my ticks. Right, quadrant 1. You see that? This is the quadrant which meets the 2 conditions. So it means this is quadrant 1. You see that? Okay. Let me go back to the question. I want you to try B and C. Okay, let me go back to the question. Right. Can you try B and C very fast? Maybe for 1 minute. And then I'll show you both of them. And then I do D. Then we'll be done. Okay, well done, cretins. Right, we have decided that we are going to make question D your homework. Okay, let's do B and C together. Then D is going to be homework. Identify the quadrant for D. Okay, that is your homework. And then after that, we just summarize our lesson. Right, now, B, we did this one, A. Right, B. Where's B? Oh, yeah. Right, where is cos theta negative grade 10? In quadrant what? Obviously, what quadrant 1 is out because all of them less than 0 means positive. Okay, less than 0 means positive. This means, less than 0 means negative, sorry. This is negative. Less than 0 means negative, okay? So where is tan theta negative? Quadrant 1 is out because all of them are positive. Oh, let me write my cast to just remind me. So cos theta should be negative in quadrant 2 and 3. I tick that. Okay, done with cos theta. I go to tan theta. Where is tan theta negative? Tan theta is positive in quadrant 1 and 3. So it means tan theta is negative in quadrant 2 and 4. So I tick that. So which quadrant meets the 2 conditions where cos theta is negative and tan theta is negative? It is quadrant 2. You can see with 2 ticks there, it means that the 2 conditions are met there. So that's quadrant 2. Okay? Right, let's go to C. Right, what is the meaning of this? It means the angle is between 0 and 180 degrees. So which quadrant are these ones? Where the angle is between 0 and 180 degrees. It should be quadrant 1 and quadrant 2. You see, these are the angles between 0 and 180 degrees. Okay, cast. Right, and then where is cos theta negative? Cos theta negative, because less than 0 means negative. Cos theta is negative in quadrant 2 and 3, because cos theta is positive in quadrant 1 and 4. So 2 and 3, that's why cos theta is negative. I tick that. See? Which quadrant is that? Quadrant 2. I forgot to tell you what you do after that. After identifying the quadrant, then you will know where to draw our terminal ray. But we're going to discuss that in our next lesson. Then you know that my terminal ray is going to be here. And then I'm going to show you a nice way of drawing our terminal ray and calculating this thing. Okay? And then you'll never lose marks on this topic. Right, so we said, let's make question D the homework. If you did not copy it, just do that. You don't need to copy the whole thing.